guys, if you could please notice that this is an exponential function. I know it's an exponential function because the variable is an exponent. It has to be an exponent. All right, what we're going to do here is we're going to plug in some inputs and get some outputs. And the inputs that we're going to plug in are just -2, -1, 0, 1, 2. We're always going to keep it that simple. All right. When we plug in -2, remember that's going to be 3 to the -2. It's on the wrong side of the fraction bar. So 3 to the -2 is 1/9. 3 to the -1st is 1/3. And then remember 0 power is always a 1, bless you. And then, 3 to the 1st, 3 to the 2nd. So this is a 3 and a 9. All right, let's plot these. I know these are kind of small, but just plot the best you can. So from the origin, we're going to go to the left of 1/9, 1/3, 1/9. Okay. So after you plot your dots, you can kind of see the shape of the exponential graph. However, before you graph it, remember, no matter what kind of number you put in for the exponent, it is absolutely impossible, mathematically impossible for you to ever get 0 or for you to ever get a negative output. So you have to draw your asymptote here. So your asymptotes, every time you draw a graph in that blue packet, you're going to draw an asymptote. And remember, for exponential, the asymptote is y equals k. That's your asymptote for exponential. We didn't have a k value, that's why it's 0. All right, let's go ahead and draw the shape of the curve, y'all. Please don't forget arrows on your graphs here. And then let's answer those blanks over there on the right side. Okay, look, domain. Oh, so easy because it's a function. Functions always have the same domain. If you see f of x, it is always negative to positive infinity. You can plug in whatever number you want for an exponent, but there is no way you're ever going to get a negative or a 0. So the range is from 0 to infinity. Let's do end behavior. It's been a while. Remember, end behavior has those little arrows. So as x approaches negative infinity, I'm going to draw a semicolon. And guys, I'm going to be consistent. If it starts with f of x, I'm going to continue to use that notation. All right, here we are on the negative side of infinity. As our inputs get smaller, what happens to our outputs? They approach 0. All right, let's take a look at the other side. As x approaches positive infinity, let's analyze f of x. Here's positive infinity. So as the x values increase, the outputs increase also. So we're going to write it approaches positive infinity. And don't forget your asymptote. Your asymptote is going to be y equals 0. Because that's where the impossibility starts. That's it. Any questions on number 1? Let's take a look then at problem number 2. So for problem number 2, you're going to have a reflection happening because you have a negative up there in your exponent. But y'all, we are still using the same inputs. This is still going to be -2, -1, 0, 1, 2. The whole time, these values never change when we plot our graphs. We keep our numbers small here. Right, here we go. So look, when you take 2 and raise it to the -2, that turns into a positive. So 2 raised to the -2 because of the negative x, that is going to be a 4. 2 to the negative first is going to turn into plane 2. 2 to the 0. And then look, here's where your fractions start happening. So 2 to the negative first is going to be 1/2. 2 to the negative half, or to the negative second, is going to be 1/4. So the best you can, let's plot these ordered pairs from the origin. And then before I draw my curve, guys, I do go ahead and plot the asymptote. It kind of makes it a little easier for me not to drop below that line. So there we are. And again, your domain is still negative to positive infinity. And your range is still the same, y'all. It's from 0 to positive infinity. But your end behavior is different because it's reflective. All right, look, here's your end behavior. As x approaches negative infinity, let's take a look at what happens with the outputs. Here's negative infinity. The outputs are increasing here. So it's approaching positive infinity. Let's analyze the other side. Let's analyze the positive infinity symbol. All right, here's the positive infinity symbol. If you notice, it's getting closer and closer to 0. And again, your horizontal asymptote is y equals 0. 3. For problem number 3, we have a base that's less than 1, which means the graph is going to go down. It's going to go from here down to here. But we also are starting to have a horizontal translation. Let's address the horizontal translation. We need to find HK. HK for this problem is -2, 0. Remember, the H is always opposite. That is where the graph is going to start. We are not going to plot ordered pairs from the origin like we did on the front. We're going to plot from this. That little point right there. So, guys, HK is like your new origin. Always plot HK because that's the new place to start. Once you plot HK, you have addressed the transformations. Everything else is exactly the same. We're going to draw a T-chart. We are still going to use the same numbers. Still -2, -1, 0, 1, 2. All right, so this 1/4 raised to the -2, it's in the wrong spot, so the whole thing's going to get flipped upside down. 1/4 to the -2 is 16. This would be 1 to the -2 over 4 to the -2. And that is in the wrong spot. All right, 1/4 to the -1st is 4. Same process. Any questions on that? Yes. Power is 1. So 1/4 to the 0 power is 1. Right here, 1/4 to the first power is 1/4. 1/4 squared, of course, is 1/16. All right, so we have our inputs and outputs after it has been translated 2 places to the left. let's plot these based on our new origin. So guys, the first one I can't fit. -2, 16 would be way up here. Let's plot -1, 4 from our new origin. So over 1 up 4. And then we're going to use 0, 1. So 0 up 1. And then we're going to go 1 to the right, 1/4. And then remember, 2 to the right, 1/16. And by the way, guys, we got to draw that horizontal asymptote at the K value. Remember, the K value is 0 right here in this problem. So let's bold this out. Your K value is always going to go through what we're calling the new origin. So that's going to be the graph for that. Any questions on that? All right, let's take a look at problem 4. So again, for problem 4, we're going to find HK, the horizontal and the vertical translations. For number 4, we don't have a horizontal translation, but we do have a vertical translation of 1 place up. So this whole entire graph has been shifted 1 place up from the origin. Also remember, we have a horizontal asymptote at y equals 1 because we had a K value of 1. Your horizontal asymptote is always going to go through what we're calling our new origin, our new starting point. All right, let's go ahead and plot some ordered pairs here. We're going to use the same numbers, -2, -1, 0, 1, 2. All right, and remember, we're only applying it to the base. So 3 to the -2nd power is going to be 1/9. 3 to the -1st is 1/3. 3 to the 0, of course, is 1. And then our last two numbers, guys, are going to be 3 and 9. Let me just put it on my chair. Thank you. So we're going to plot these from our new starting point. Remember, everything has been shifted up 1 place. So 2 units to the left, and try to just estimate where 1/9 is. 1 unit to the left, 1/3. Here's 0, 1. And then +1 up 3. And then 2, 9 will fit on this graph, guys. Up over 2, up 9 places. So the shape of the curve takes place. We're starting to see it. Make sure you have arrows on the ends of everything, and that's going to be the shape of that graph. All right, we're going to do one more. We're going to do problem number 6. Let's look at problem number 6 because you have a horizontal and a vertical translation. All right. For problem number 6, let's go ahead and identify HK. HK is going to be +3, -2. And while we're at it, let's go ahead and identify the asymptote. The asymptote is going to be y equals -2. Let's go ahead and plot this stuff now. So my new starting point, 1, 2, 3, 1, 2, it's going to be right here. Let's go ahead and draw that horizontal asymptote. All right, T-chart still the same, -2, -1, 0, 1, 2. All right, when we plug in -2, it's just to the 4, just to the base. So -2 is going to give you 1/16. 4 to the -1st is 1/4. All right, then we got 0, 1, then a 4, and then our last point is 2/16, but we're not going to be able to fit that last point. All right, let's graph this. Remember, everything is from our new starting point, from our translations. So 2 to the left, up 1/16. All right, so that's going to be the shape of your graph.